So far we've talked about types of series that we can recognize: geometric series, p-series, collapsing series. But there are all types of series out there where we can look at the nth term and we don't know what type of series it is. We don't know whether that series sum converges or diverges. And so there are other tests that we have to learn. This test, the nth term test for divergence, will be the first test that we run. If we look at our nth term and it's clearly not geometric and it's clearly not a p-series and it's clearly not a collapsing series, then this is the first test that we're going to run. So if the series S sub n, which is the infinite sum of all the terms in A sub n, some infinite sequence, if it is convergent, then there's one thing we can count on. All convergent series, when I put the nth term for the sequence in this limit, I will get 0 as a result. All convergent series share this quality. The problem is that some divergent series share that quality as well. Some divergent series have A sub n, where when we put it in this limit and run n toward infinity, we also get 0. Those we can't find using this test. If we put our nth term into this limit and we get 0 for an answer, that's inconclusive for this test. It tells us nothing about what our nth term is doing. Remember, here's a series that is a p-series where p equals 1. It's the harmonic series, and we know this series diverges. But if we put that nth term in this limit, we're going to get that for an answer. So there's one of the many series that fall into this subset of divergent series. This test will not find those series for us. The subset that we're looking for is the whole set of divergent series where that limit doesn't go to 0. Because there are two possibilities that we're going to get from divergent series. We're never going to get doesn't equal 0 from any convergent series. We can count on that. So if we run this limit and we don't get 0, we absolutely know we're dealing with this subset of divergent series. And we can use this test to justify why we're saying this series must be divergent. So this work is based on the nth term, not the nth partial sum. We're looking for what the last few terms in our sequence are doing. If the last few terms in our sequence are not getting sufficiently small enough to force that limit to go to 0, then we are guaranteed that series diverges. So it's a shortcut for us to determine if the series diverges. It's quick because all we have to do is find this limit and determine it doesn't equal 0. But make sure this is in your notes. If this limit does equal 0, we have to find another way to determine the series behavior. We have to run another test. We have to run another test. And yes, we have more tests to learn. So we're not after this set of divergent series. This limit's not going to tell us anything about those. We could not use this test to determine whether the harmonic series was convergent or divergent. The harmonic series fails the nth term test for divergence. But there's a whole other set of series out there that won't fail. Because all convergent series equal 0, and only some divergent series equal 0 in this limit, we're after the subset of divergent series where this limit doesn't equal 0. So remember, there are many divergent series where this limit will equal 0. It is not true, that if the limit equals 0, the series is convergent. Not true. If the limit equals 0, then the nth term test for divergence fails. So this is called the nth term test for divergence. You are testing for divergence only. This test can never tell you anything about convergence. So if you run this limit and you get any value out of this limit besides 0, or you can't evaluate this limit, your nth term's jumping around all over the place and the limit doesn't exist, then your series diverges by the nth term test for divergence. That's how you are going to justify that you know your series diverges. And remember, we have to state our justification. This will only tell us about divergence. This test tells us nothing, absolutely nothing about convergence. So if you run the limit and you get 0 as a result, if you get this out of the limit as a result, and this is the first test you're going to run, every series they give you, in your head, you're going to take that nth term, and everywhere there's an n, you're going to put in a huge. If you do that in your head and you don't get 0 for an answer, you get anything besides 0 for an answer, then your series diverges. If you do get 0 for an answer, the nth term test for divergence fails. This test can fail. You have to run another test. All right, let's work some examples. Here we have a series 1 over k to the negative 1/100th. Well, the first thing we're always going to do from this point on, if we do not recognize that we have a geometric series, a p-series, or a collapsing series, the first thing we're going to do is run the nth term test for divergence. If we cross the line here using algebra, we get to change the sign. That limit goes to infinity. So this series diverges by the nth term test for divergence. You must always state what test you ran to justify your choice of divergence or convergence. Now, this one is just as easy for us to verify our work because this one is a p-series. The one we just did is a p-series where p is negative 1/100th. That's less than 1. We know for any p-series where p is less than 1, the series diverges. So that's a good way for us to double check our work. Up here, for this series, not a geometric series, not a p-series, not a collapsing series, so let's run the one test that we know so far. The limit as n approaches infinity of n over n squared plus 1. We're still going to do correct limit work. Remember, I said you're going to run this limit over and over and over again. You have to know what the result is telling you. This result is telling us we don't know what this series is doing. This series could converge, or it could go ahead and diverge. We have absolutely no idea. This, the nth term test for divergence, fails. We have to run another test. Unfortunately for us right now, we don't know any other tests. Our subsequent lessons will teach us tests where we can that we can use. But here the nth term test tells us nothing about that series. So let's go back over here. The limit as k approaches infinity, 1 over k to the negative 1. Cross the line, change the sign. This series diverges. And it diverges by the nth term test for divergence. Now again, you're really just, every time you're given a series and asked to see whether it converges or diverges, you're just going to run the nth term test for divergence in your head. If you get a useful result, then you write that limit, the whole thing, and your result, and justification for your choice, then you write it on the paper. But we're usually just going to run this in our head, and because lots and lots of times we're going to get 0 for that limit. All right, let's do this one. The limit as n approaches infinity of that nth term. This is infinity over infinity. So the limit as n approaches infinity, 1/2 pops down front, negative 1/2, that's over 2n. Let's clean it up a little bit so we can tell what's happening. This is 1 over 1/4. Are we okay with that? This is actually down here. And this n to the 1/2 comes down here. We already have an n there. This is going to 0. Your test fails. Find another test. And we're going to learn more tests in subsequent lessons. But I think you're getting the general idea. The limit as n approaches infinity. This is actually k squared. That's definitely diverging. It's not enough to just say diverges. You have to show the AP reader the test by the nth term test for divergence. I have every year students ask me, do I have to write all that out every time? Yes, you absolutely do. No doubt about it. You have to write the full name of the test that you're running. So let's do this last example really quickly. You can run this in your head. The only place there's an n is in the denominator. When I plug in huge values for n, this fraction is going to 0. The nth term test for divergence fails. And this is what you're going to do many times. The nth term test for divergence fails. You run it in your head. You see that it fails. You don't have to write that it fails, but you're going to run it in your head. You're going to see that it fails. This is your clue to find another test. You have to find another test. So you're always going to start by running the nth term test for divergence in your head. If you get a good result, then you write everything down. All right, all of that has to be shown. If you don't get a good result, you don't have to write any of this down. This is just your clue that the nth term test is not going to work for you. Find another test. All right, so there's your first test for convergence or divergence, specifically a test for divergence. Come to class next time. We'll do kind of a mixed practice on all different types of series to see if you can recognize geometric, collapsings, and p-series, and also to see if you can determine divergence by using this test.